Hello, today we're going to talk about brazing with nitrogen. Many of you are already using this technique. If you're not, one of the downfalls that you can run into is oxidation. You know, while you're brazing a line set and on the outside you get this charred black powdery substance, kind of like soot. Well, it really is very close to soot, but really what's happened is the oxidation process. It doesn't matter how good you are brazing, it happens naturally. So what we do to overcome that process is we get the nitrogen out of the inside of the line set, because what you see on the outside can also happen on the inside. Now, if the oxidation takes place on the inside, we can't clean it out as easily as we can on the outside. So what happens is when the refrigeration system turns on, the refrigeration oil acts as though it's a cleaning agent. They're tremendously good at scrubbing the inside of this system. So all of those little carbon flakes that are building up will soon get swept away and get stuck in some of the smaller parts of the system, mainly your metering device or possibly your distributor tubes. Any of those areas are subject to damage if nitrogen is not used during this process. So what we're going to do is look at how do you do it. Okay, first of all, you got to be safe. No matter what kind of brazing process you're using, always have some way to put out an accident. So right here's our fire extinguisher. Next of all, you got to have some way to bleed nitrogen in there without having too much of it bleed in there. So what do we use for that? A low pressure nitrogen bleeder. This is called a flow meter from some people, or a low pressure nitrogen bleeder. And as you can see, we've got our high pressure regulator turned on its side so that our low pressure regulator or a flow rater or a flow meter can then be straight up and down so that we can see the balancing ball inside of there and control our gases from here. You're going to set your high pressure regulator down to about 40 psi, somewhere between 40 and 50 psi. Most manufacturers of the flow rater are going to be at their max amount for a low pressure bleeder, having the incoming pressure being more than that. So we want to make sure that we're within manufacturer specs. Next, we want to have our flow rater set in such a fashion that you can't hear the nitrogen going through. You can't see it coming through. The idea is not to build up pressure, so we want a small amount, somewhere between 2 and 5 psi would be just fine. Some prefer a little bit more. Your idea is to just get rid of the air that's inside of there, the oxygen, so the oxidation process doesn't take place. Now, this doesn't make your brazing process any easier. It also should never make it any harder. So you shouldn't build up pressure that will blow nitrogen out of those joints and force the brazing compound out of the joints. So once we've got the nitrogen flowing through there and we've got our joints all put together, one other thing that we want to do is we want to make sure that we've got something to protect any of our sensitive parts, namely the service ports. Now, when you see my gauges hooked up like this, some of you guys are thinking, you know what, that guy's crazy. He's going to melt his valves. Okay? However, there are worse things that could happen. This is the lesser of a couple of different evils. Okay? I'm using the Cool Gel product, which there are many like it, and this Cool Gel product keeps the heat off of these gauges. Now, if I wasn't using the gauges right there, for instance, one thing I've done in several different locations to try and find the best method of doing this is I would put the gauge only on one side and bleed the refrigerant through all the way through the system to the other side while I'll be brazing here on the other side and keep the Schrader valve out so that it can clean, go through and through. Now, as I was doing that, I'm brazing, everything works just fine. However, the heat from my torch is now going to be blowing through to the service valve. Now, Cool Gel can protect the outside, and we'll show you how good that protection actually is here in a moment. However, it can't protect the inside. So when you're blowing through this way and you're brazing on this side, your heat from your torch on the inside of that line set is blowing into those service valves and can potentially warp those service valves or damage those service valves. So what I've done here is I've got both sides attached at the same time while having my metering device off on the other side, so I've got it clean through and through, and I have my 1/4-inch port from my removed expansion valve out, and the Schrader valve is out as well, so it can naturally bleed out the other side, and I'm not building up any pressure in here because we wouldn't want to do that. Now, let's look at this cool gel. Let's see how good this stuff actually works. I've taken an ordinary styrofoam cup. Now stay with me. I'm going to spray this on here. We'll spark up the torch. Dial it back to a neutral flame. Get it good and spread around on here. This stuff is absolutely amazing. Watch this. Right on the styrofoam cup. Let me show you what happens when it's not on there. Immediately, boom. Okay, this is some great, great stuff. Okay, so to the brazing process. We've already got our torches on. We've already got our brazing compound in hand. We also have our nitrogen flowing through. So let's get this show on the road. Excellent. And there you go. Now safely turn down your torches. Shut down your regulators by twisting the knob all the way out on your regulators. Let the excess amount of gas flow out of your hose. Shut down the actual bottle. And you now have learned how to braze with nitrogen.